In this video, we'll look at problems 5 through 8. So let's start with number 5. So we take a look at that, and we first, you want to look at things and take a look and see, well, I've got an inner function and an outer function. The inner function is 5 minus 2x cubed. So if I let u equal that, then the derivative is going to be negative 6x squared. And you don't really need to worry about the numbers in front. Well, you do it sometimes, but on this one, look, we've got an x squared. And so we know the derivative of something x cubed is going to have an x squared. So it looks like we have some potential here. So let's go ahead and write down that u is 5 minus 2x cubed. And du will be negative 6x squared dx. Let's come over here now, and we can take the 9 out front, so it's no longer relevant as far as for our integrand. And we have x squared on top, and we have the square root of 5 minus 2x cubed on the bottom. And then times dx, of course. So now when we look at this, we've got the square root of u here, because u is 5 minus 2x cubed, so we get the square root of u on the bottom. The du is negative 6x squared dx. All we have is x squared. So in order to have a 1 over radical u du, we'll need to have a negative 6 times that x squared. So we'll simply multiply it by negative 6. And of course, if we do that on the out front, we've got to divide by negative 6. So now we have what we want. So we have, if we reduce the fraction, it'll be negative 3 over 2. And we have the integral of the du is on top. Negative 6x squared dx is du. And then it's over radical u. And to make that easier to do, we'll write that as the integral of u to the negative 1/2 du, which is negative 3/2. And if we add 1, we get 1/2. Divide by half, it's times 2. So it'll be times, negative 3/2 will be times 2u to the 1/2 plus c. And of course, since u is 5 minus 2x cubed, this will be, these 2's will cancel, negative 3. And again, the u is 5 minus 2x cubed. It's raised to the 1/2 power plus c. That can be your answer. If you wanted to, you could write it as a square root of 5 minus 2x cubed and then plus c. Either answer is correct. All right, so let's take a look at the next one. The next one is tangent cubed secant squared. Now, hopefully you recognize that the derivative of tangent is secant squared, so that should be a pretty easy one. U is going to be the tangent of x. Du is secant squared x dx. And so we'll have the integral of u cubed times du. Because here's my u, tangent, and it's cubed, and then we have secant squared x dx. That's my du. We do have to change the bounds if we're going to use u's, and I'm going to go ahead and do that. U of pi over 6. That means we have to plug pi over 6 into the tangent of x, or in for x and tangent of x. So it's tangent of pi over 6 will give me what the u value is when x is pi over 6. And so the tangent of pi over 6 is radical 3 over 3. And then u of pi over 3 means I will be plugging in pi over 3 into x. And when x is pi over 3, the u value is going to be the tangent of pi over 3, which is radical 3. So our bounds are now radical 3 over 3 to positive radical 3. We take the antiderivative, it's 1/4 u to the 4th. We go from radical 3 over 3 to radical 3, and then we plug it in. 1/4 times radical 3 to the 4th minus 1/4 times radical 3 over 3 to the fourth. So let's finish this up. 1/4, what is radical 3 to the fourth power? If you struggle with that at all, remember radical 3 is 3 to the 1/2, and then 3 to the 1/2 raised to the fourth is 3 to the 4 times a half, which is 2, 3 squared. So that's going to be 9, and then minus 1/4 times, and again, the radical 3 to the fourth is 9, and then 3 to the fourth is 81. So this becomes 9/4 minus 9 over 81 reduces to 1 over 9. So that's going to be 9/4 minus 1 over 36. So we will need a common denominator, and the 9 over the 4. We're going to multiply 4 by 9 to get 36. So you multiply the top by 9. We're going to have 81 over 36 minus 1 over 36. That equals 80 over 36. And we can divide those by 4, and we will get 20 over 9 as our final answer. Next, we have number 7. We quickly see that we have e to the sine of x, so that's a composition of functions, and the inner function, of course, is sine of x because it's e to the sine of x, and so u is going to be the sine of x, du is going to be the cosine of x, which means what we really have here is the integral of e to the u and du, because, I'm sorry, du is cosine of x dx, and of course that's right there. My cosine of x dx is my du, and u is the sine of x. So that's just simply going to be, the answer is going to be e to the u plus c, which is simply e to the sine of x plus c. So that was a pretty quick and easy one. Next, we have to evaluate the integral from pi over 6 to pi over 3 of the tangent of 2x dx. Now, this one's a little tricky. So you might just try to jump in here and say, okay, the inner function is 2x, so u is 2x. Du will be 2 times dx, and so it looks like I have the tangent of u du. So as you jump into this, and here we go, you would say, okay, I've got to change my bounds. U of pi over 6 is equal to 2 times pi over 6, which is pi over 3. And u of pi over 3 is equal to 2 times pi over 3, which is 2 pi over 3. So we've got our new u bounds. So this will be equal to the integral from pi over 3 to 2 pi over 3 of the tangent of u du. Except for it isn't going to be that, because du is 2 times dx, and we didn't have a 2 times dx, so you'd have to put a 2 there and a 1/2 there. Don't forget that. So this is going to be 1/2 times the integral of the tangent of u du. And so now we could just go ahead and, take our antiderivative. Well, we can't take our antiderivative real easy. We have to make the tangent sine over cosine in order to do that integral. We've done that one a number of times. But before we do that, I want to show you something that you have to be really careful about. Remember, the tangent has asymptotes. And do you remember where those asymptotes are? Well, hopefully you do. Remember, we always go 1, 2, 3, 4. So I've got 2 pi here, and I got pi, and I got pi over 2 here, and 3 pi over 2 on the third tick mark. Same thing happens on the other side. But we only have positive values, so we have an asymptote at pi over 3, and we also have one at 3 pi over 2, and negative pi over 2. The tangent graph looks like this. We're graphing between pi over 3 and 2 pi over 3. Now, where's pi over 3? That's a third of pi. Pi over 3 is on the left side of pi over 2, right? It's a third of pi. This is half of pi. A third of pi is less, so it's inside of here. 2 pi over 3 is on the other side of this asymptote because it's 2/3 pi, which is bigger than a half. So you basically have, if I'm going to mark this here, 2 pi over 3 would be like right, or I'm sorry, 1 pi over 3 would be there, and then 2 pi over 3 would be over here. So that means we're trying to find the integral value between there and there. That's not going to work. We can't do this. And so what we will say is that the integral does not exist. Okay? Because we cannot evaluate an integral where there's infinite discontinuity. Not in this class. When you get to BC, we do some things with limits, and you can do it, but not now. So that's a tricky one. Just wanted to throw that in there to make sure we got that taught to you and you talked about it. You won't see that a lot, but it could pop up.